Welcome class, welcome class. All right, hey, as you're coming in, as everybody's getting seated, I'm going to give you all about 7 minutes to do the daily warm-up. Today we're going to go over surface area, and so this is going to give us a little bit of introduction. Just a heads up, this is going to apply what we've learned about area with normal polynomials or polygons, and you should do the best you can. We're going to go over it. I'll give you all about 7 minutes. Here you go. Alright, so our question was, a house is covered in bricks. Let's assume that the house has dimensions of 24 feet by 24 feet by 12 feet, and each brick is 6 inches by 3 inches. About how many bricks are used? Alright, so who wants to answer this first question of the two? Jimmy, perfect. Alright, so what did you do first? Okay, you drew a picture? Okay, perfect. So did your picture look something like this? Oh yeah, it's a perfect house, Jimmy. I like that. So we know that it's a 24 by 24 by 12, right? And these are all in feet. This is essentially important in this question, considering we're going to be switching later on. Okay, so that is the first thing you did. You drew a picture, right? What was the next thing you did? Okay, so you figured out what this wall, how much area this wall is covering, right? Alright, so it looks something like this, correct? So 24 times 12. Alright, and what does that equal? 288. Can anybody confirm that? Perfect, thank you, Sarah. Alright, so 288 feet squared, right? Because we're multiplying feet by feet. Alright, and so that is this wall right here. Well, fortunately though, this is a house that has 4 walls, so what do we have to multiply this by? Times 4. Alright, perfect. So what does that give us right there? How many feet? 1,152 feet squared, right? Alright, everybody got that? Alright, sweet, we're on the same page. Alright, now what's the next step? The next step is we're going to have to find out how many bricks we can put on. Alright, so the difference between, what is the difference between this and this? I mean, obviously they're different numbers, but they're in different units. Alright, so we've got 6 inches over, how many inches are in a foot? 12, perfect. Alright, and then we've got 3 inches over 12, right? So that's essentially saying half a foot and a fourth of a foot, correct? Perfect. Alright, so what do we do when we multiply these? Multiply them across, right? So we've got 18 over 144. What does that reduce down to? 1 over 8. Perfect. And this is feet squared also, because this is in feet and this is in feet. Alright, so now we've got how much one brick covers on the house. So how many bricks would it take to cover 1 foot of a house? Alright, so times 8 equals 1 foot, right? Because it's going to take 8 bricks to cover 1 square foot. Alright, so that being said, we know that there is 1,152 feet to be covered. So what are we going to do? Jonathan, alright. You said we're going to multiply 1,152 by 8. That looks pretty good to me. Everybody agree? Everybody agree? Alright, perfect. And so how many does that give you? That gives you 9,216, correct? And what is that? What does that tell you? That's 9,216 bricks that we're going to use to cover this house. Alright, so now the second part of the question, that was the first part, so now the second part. Let's assume that there are 4 windows. One window is, or all 4 windows are 3 by 4 feet. And a door that is 3.5 by 7 feet. Alright, so now we're going to, just like we drew earlier, we're going to draw our house. But we're going to add little windows, right? And we're going to add a door. This one only has 1 door because that's what it says in the problem, correct? Alright, so now, if we are going to, again, continue to cover the house in bricks, how many bricks are we now going to use? Alright, so now, what do we have to do first? Okay, so we've got to figure out the area of the door and the area of the windows, right? Alright, so let's go ahead and do that. So we know that it's 3 feet by 4 feet, correct? So that's going to equal 12 feet, and that's for one window, correct? One window. Well, how many windows do we have? We have 4 windows. Times 4, correct? So we've got 48 feet squared that we have to fill in. Now, how many bricks is that going to take to cover up these windows? So in order to figure that out, we've got to multiply this by 8, and so that gives us 384 bricks. Perfect. All right, now we're not done yet. Now we've got to figure out the area of the door. So the area of the door is 3.5 feet times 7 feet. And that's going to give us how much? Oh, perfect, Jonathan. 28.5 feet squared. That's what we're going to have to fill in. So again, how many are we going to multiply by? We're going to multiply by 8. And that's going to give us 96 bricks. Alright, so that being said, what does this tell you? This is the area that one window would take up, right? So this is, or I guess 4 windows would take up. So, and then this is the area that the door is going to take up. So what do we have to do to this number right here with these numbers? We've got to subtract them, correct? Alright, so let's subtract. When we add these together, that's going to give us 580. So let's subtract 9,216 by 580. And what does that give you? Alright, Martha, you're right. That gives us 8,636. And so now we know that it's going to take 8,636 bricks, as long as we don't break any, to cover this house that has 4 windows and 1 door. Why is this important? Where would you use this in the real world? Obviously, construction. If you are going to be a construction worker, if you're going to buy materials, you're going to have to understand how much materials you're going to need in order to cover a house or a building or a garage, something. So yeah. All right. Now, next, great job on the warm up. We are now going to flip into, into our discussion for the day. The reason why I started off with that question, I know it's a little bit difficult because it had lots of steps, but the reason why I started off with that was because we have already discussed how to find the area of objects, right? So we know how to find the area of a square. The area of a square is length times width, right? So now we are going to add a little bit to that. We're going to figure out the area of 3-dimensional figures. And so area, or surface area, is the total area of the faces of a solid figure. Perfect. Alright, now there are 2 types of surface areas. And that's going to be really the trick about today, figuring out which surface area a problem is asking for and really what it means. So there are 2 types. There's lateral and there's total. Lateral, anybody take a guess what that means? That was close, that was close. Lateral means, in simple terms, the visible sides. Alright, and so that would basically be all sides except the base. Except the bases. Base or bases. Base/bases. And so, that being said, now that we know what lateral is, what do you think that total is? Exactly, so it's everything, all sides, including the base. All right. Why would that be important? Perfect. Why is that important? Okay. So you think that if we are trying to find the total of the base or the total surface area, maybe we would have to buy more materials. That's very good. Yeah, that's spot on. You see if you're buying materials, let's continue assuming they're all construction workers. If you're buying materials, you're going to have to figure out if you are just covering the outside, or if you're covering the bottoms and tops, or what exactly you're going to be doing. All right. So now I want y'all to get into groups of 3, and on your technology, whether that's your phones or your laptops or your classroom. We've got a classroom set of iPads. We are going to fill out this chart right here. All right, and so this chart is basically how we are going to continue for the next couple of lessons. What you're going to have to figure out, you're going to have to figure out what a figure looks like. So you're going to have to draw a picture. You're going to have to find the formula for your lateral surface area, and then you're going to have to find your formula for your total surface area. I'm going to give you all about 10 minutes for this. And so you're going to figure out 1, 2, 3, 4, 5, 6, 7, these 7 formulas. And so, yeah, there you go. Proceed. All right, thank you so much. All right, so now we have, everybody has answered, filled out the chart so far? All right, perfect. All right, so now we're going to do, popcorn. We are going to continue filling this one out, just to make sure that everybody is on the right page. All right, so, Garrett, what did you get for, how do you draw a rectangular prism figure? All right, so you put 2 squares on either side and then connect the lines. Yep, that's very good. All right, so now what was your formula for lateral surface area? All right, so you found 2h times length plus width. Perfect. All right. Anybody agree with that? Disagree with that? All right, everybody's in agreement. Perfect. All right, so now we're going to find the total surface area. What is the formula for that? Martha. Alright, so you've got 2 times length times base plus base times height plus height times length. That's a lot to keep at or look at, but that's exactly right. Can you explain that? Okay, so you're saying that once you distribute out all of these, or once you distribute out the 2 to all of these, that it's going to show you exactly your faces, the area of each face. Yeah, that's perfect. Without numbers, that is a little bit hard to visualize, but we are here in a couple minutes. We're going to show you some examples, and so then we'll apply that. All right. So what is the lateral surface area for a cube? Oh, Zach, perfect. Yeah. All right. So you got 4a squared. All right. And so what is the total surface area? 6a squared. All right. Explain that to me real quick. So why is this one 4 and why is this one 6? Okay, because the lateral does not include either of the bases. Yeah, that's exactly right. Just like what we were talking about up here, that's the definition of lateral. Because there's only 4 sides,